saw the new trailer for Boundary, which, to be honest, looks really interesting. But the idea of having a zero gravity FPS really ticked with me, so that's what we're going to do. Okay, I haven't played the game, obviously, it's not out yet, and I wasn't at Gamescom. So let's try and recreate, well, not all of it. Obviously, we're not going to have graphics like this. And okay, so let's try the main mechanics. We won't care that much about shooting at this part. Maybe if there is a lot of interest, maybe we can add it and make, add multiplayer as well later, and so on and so on. So I have a level. Okay, it's pretty much a kit bust spaceship or whatever, and we're basically in space, or So let's create our controller. Now, this is going to be a really simple controller from what I figure. So let's start with the basics. Let's create our folder. And I do have my main camera, and I do have a weapon underneath it. We're not going to shoot on this part. I just want the weapon just for us to be able to orient ourselves a little bit better inside the world. So I'm going to create an empty game object, and in this case I'm going to create it underneath my camera, since this is going to be an FPS, and I'm going to unparent it and just leave my camera over there. So this will be your controller. Okay, then on this we're going to add a rigid body, and we're going to let's add Capsule Collider. Okay, so hitting play now, it will do pretty much the same thing it's doing on everything. It will just fall down. Let's raise the height to 2, and I would like to bring this down a bit. We can either do this from here, so let's say, yeah, okay, something like this. Okay, so he will still keep falling down. So removing the gravity will allow him to basically just stay in the air. Now let's say we added some force. It will start moving, and so on and so on. Okay, so we pretty much just want to add some control and some force onto this. So let's call this controller, or let's call this FPS controller, and let's open it up. Okay, so we're here. Let's add our namespaces. We don't really need an update. Well, we do need them, but we're going to write them again. Let's add the variables we're going to need. Of course, we're going to need the rigid body first. Well, we are going to need the animator, but right now we don't actually have it. So I'm going to add the update to this. And on start, first of all, we're going to get component rigid body. Okay, just to make sure we are all on the same page, use gravity, will set it to false. So now let's create our controls for multiplayer. First of all, we would like to get horizontal and vertical, and actually I'm going to do this kind of differently. Let's say move, not on animator, move. Let's say move, and this I want, well, this can be public, yeah. And we have our vector 3 move direction. Okay, so say we have our move direction, then that will mean that on your rigid body we're simply going to be adding force on the move direction multiplied by movement speed. Okay, let's say if this is 1, then public float. Let's add. Well, okay, we can add boosts and stuff like that later if we want to make this into, an actual game. Let's start with the simple things. Okay, so I usually like to split the directions and our inputs. But in this case, it will work like this as well. So we have our vertical, then we want to create our move direction. And that will be from our own transform.forward multiplied by the vertical. And then move direction plus transform.right multiplied by horizontal. Okay, these two are normalized because we want the vertical and the horizontal. So then that means we simply need to call move based on your move direction. And it will make him move. Now, because we are moving with physics, we could turn this into fixed update, although inputs will only work on update, so we're only going to be updating it on, this is only going to be updating normally on update. Okay, so let's try with update first and see how that works, and then worry about changing which goes into fixed update and which doesn't. Okay, the other thing that we can add is, of course, we want to have an axis for upward and down. So I'm going to say, let's say we have horizontal, vertical, up, down. I'm going to do input get axis up, down. Then on that move direction, we now want to add transform dot up because it's going to be relative to the camera, and this is because we are in a first person, so that means our transform will always be looking towards where the camera is looking at. So I'm going to save the transform, my own transform that is, and I'm going to be using this because when you're using the transform just like that, it's not really a shortcut, but you have to go through the entire hierarchy, so we can optimize it slightly with this. So even with just this amount of code, we can go in, we can add it to our controller. Okay, and if we go also and add our inputs, we should be ready to start moving. I'm going to duplicate the vertical and I'm going to say up, down. Then negative button will be C and positive button will be space. And we can delete this and this. And I don't know what's actually decrypting, but I think it's one of the skies. Download some skies with this. So I want to delete jump because it uses space as well, and maybe we can delete this as well. Okay, so now have up and down. This needs to be up and down. For a controller movement, just add one of these and just decide which one you want to have an up and down for your controller. So hitting play. Okay, and you can see now I am able to move around, and because there is no gravity, it's going to remain constant. Like if I press the right, you can see there's nothing to counter that position. There's nothing to counter us and put us back. So we kind of float like this. Obviously, we do not want to be rotating like that when we hit something. So we need to go on the rigid body first and then block rotation on the X and on the Z. We're still going to be able to rotate left and right, actually, but we're going to handle that. Yeah, maybe not X, maybe we can remove the X, we'll see. Okay, so we can move around, but as I said, we're going to keep going on those positions, and we probably don't want to have any of that. So we're going to set angular drag to 9 and 9. Okay, so now we need to see how we actually want to stop going. If there's no movement, then we would like to basically tailor back our directions. So we are adding the force on our rigid body, but we could also say that we can take the velocity of the rigid body and start lerping it back. Okay, so whatever that velocity is, tailor it back to vector3.0, and all that is going to come via time.delta time, and we need some speed for this, and it's better, let's say, kill velocity or velocity downtime, velocity down speed, and let's say maybe 0.4f. And then multiply time.delta time by that. Okay, of course we need to be adding that back onto our velocity. And we'll see if we are able to move around with this. Obviously, because we are in space, technically you should be able to stop right on your feet. Okay, you should be able to just move around slightly, like this. Okay, so now it probably, let's set this to 1. Yeah, okay, it doesn't actually do anything. Target velocity, back velocity, velocity. Yeah, it doesn't do anything. Let's raise the mass. Yeah, so apparently with a velocity like that, yeah, this doesn't actually affect the velocity that much. Oh yeah, because we are adding back our own velocity, not the target velocity. Damn it. Okay, let's try it with the small values now. Okay, so now we are more sliding around than always forward towards one position. We can raise it, of course, higher up, depending what you need to do. Technically, you should be firing counter thrusters just to tailor it back. Okay, so let's set this to 1. Let's set this up from inside the script just so that we know they are always correct. Angular drag 9, okay, and maybe change this to 1. I think movement speed can go a little bit higher, the 2. Okay, so this will give us the directions up and down. We didn't test the up and down yet, but I guess we can try them. We can try them later. So now, what I want to do is take another float for the pivot. I think it's called pivot on the airplanes. But anyway, we're going to call it pivot. So pivot is kind of a special right now because it's going to be a rotation direction which we're still going to get from our multiplying our transform.right by our pivot. Okay. So now we need to rotate and on the pivot, of course. So let's try rigid body dot add torque. Let's see, maybe we want relative torque actually on the rotate direction. Let's say multiply by the movement speed. Okay, so let's go and fix an input for the pivot. Duplicate this, let's call it pivot, and I'm going to do Q and E. So because I have free rotation on the X, we might not be able to rotate, so I'm going to untick it. We're still going to have angular drag, which means if we hit something we might, let's see, yeah, the torque actually doesn't work from what I can see. Let's raise all of it. As you can see, we can go up and down. So yeah, torque doesn't actually work. Let's see, do we get any errors? No. Input, we have pivot, rotate direction, add the relative torque. Okay, then let's raise the movement speed to something higher just to see if it's from that. Yeah, it's not. So let's start debugging it. First of all, I want to add a debug.log for rotate direction, just to know that this is actually working. And we want to, maybe we're using torque wrong. So let's say add torque. But I think, yeah, I think it's because of the angular drag. So let's leave it as it was. Let's remove that and let's bring angular drag after it's set to 9099. Let's bring it back to 0 and then try again. Yeah, okay. So that is rotating on the forward and down. We don't want, of course, we don't want that. We want to rotate on the Z. So let's rotate forward. So we need to find something, or we need to do something with this. Now, one solution for that, it could be, well, it will actually be to rotate with a transform and not with physics. That can be a solution. Let's try that. Okay, well, that works, as you can see. Yeah, obviously this is way too fast. We want this to be slightly movement, but as you can see, I can basically start moving around and so on and so on. and let's see how fast it's going to be dizzying, and it's a lot. So as you see, this works fine. It just has a few things that we're going to have to tailor to make them slightly more efficient. First of all, we should probably do something with the direction. I think maybe, since this is not, they are not going to be touching the ground, maybe we can get away with just using a sphere collider to this. Okay, maybe slightly bigger. Let's say radius 1, and maybe bring it down, maybe 0.8. Maybe bring it slightly down. Something like this. Okay. Yeah, obviously we don't have animation. We don't have a body since this is an FPS. So at relative torque, let's see, try the forced modes. And I'm going to change it to velocity change. So I think this will keep it constant, but we're going to have to try it. Otherwise, we might have to say, let's say torque. You have your angular velocity. Let's try setting the angular velocity to the rotate direction, and then let's do public float torque speed direction by torque speed, and let's remove this. The difference between this and this is that this will replace any torque velocity you have, while this will try and add it. Yeah, okay, so you can see that with this we can rotate, but I think it's not a perfect rotation. Like if I sit here, maybe it's because, yeah, it's not that perfect of a rotation. Maybe it's because the center of gravity is offsetted. Let's set this to 0. Let's make sure our camera is at 0, 0, 0, okay. Yeah, okay, that looks a little bit weird, to be honest. So, technically, or the way I see it, it should be rotating the left and right? Right on the center, but you see it's not that, yeah, it's not looking nice at all. You can't control this. So, we need a new method for rotating, that is. So, instead of adding this as a rotate direction, we're going to change. Yeah, we're going to try and change this directly on the transform. So taking our own rotation and multiplying that by quaternio.look rotation rotate direction, let's see what's that going to do. Yeah, maybe not. Okay, so let's hold on. Okay, so as you can see, we have perfect rotation on this. So how did I do this? I simply make it even simpler. Okay, we don't need the rotate direction anymore. We have our Eulers. We change on the Z and we simply add on the pivot movement speed. Okay, and we have our Euler angles just like that. We can subdivide this by time dot delta time to make it frame independent. Let's change this to torque speed because we're going to have to raise the torque speed much more right now. Okay, and let's say torque speed, let's try with 30 and we'll see. Yeah, 30 is too much, I guess. That's 2.1. Yeah, okay. We can play with these values. Okay, so we now have, we can move around and rotate. So now we have to change the rotation of, yeah, we basically just need to change the rotation of the camera, which also changes our own orientation. Okay, so the first one with that, well, we basically need to take mouse X, and that will be your left and right, and we want mouse Y as well. Okay, so here's mouse X, here's mouse Y. For left and right, we already have the Eulers, so we could just say Eulers dot Y plus mouse, I think it's mouse X, yeah, multiplied by, let's do a rotation speed, by rotation speed subdivided by time dot delta time. Okay, let's see if this works. First of all, we're going to have to lower these values we had here. So I think this 0.02 and rotation speed, let's say 0.05, should do a little bit of better job. Okay, and we can move around, as you can see, left and right. Maybe it's more faster than we wanted to. And maybe it will make a little bit more sense if our movement is based towards the camera, so where the camera is looking. We'll be going up and down. Okay, so for that we need a reference to, well, the camera. So transform, camera, transform. I know that this is going to be a camera beneath my object, obviously, since this is an FPS component, so I can just get it like that. Now, instead of using my own transform, I can just say for left and right, change the, add the velocity based on the direction of the camera and not this not this object. Okay, and then the Euler angles are going to be based on this. Yeah, okay. So next we need to add on the rotation of your camera, so it can actually rotate up and down. Okay, which means we can get the camera Eulers, then on your camera Eulers, that's not how you write Eulers, anyway, dot, I think is X, equals or plus, or well, okay, we could say equals, I guess. So you can have your float tilt angle, set it to 0, and then we can set this to tilt angle, and on the tilt angle we're going to be adding mouse Y by rotation speed subdivided by time dot delta time, and then we want to add that back on the Euler angles of our camera. Let's rename it. Okay, let's set the rotation speed even lower and let's hit play. Okay, let's see where the error is. Oh yeah, this needs to be get component children, not get component. Simply like that. Okay, let's compile. and hit play. Okay, the only opposite is that the mouse is wrong, oriented wrong. And right now, not only it's oriented wrong, but you can see that we are not rotating. We are rotating on an angle, and I think that is because there is yeah, we have something wrong on the X. Well, first of all, let's fix this. This will be minus, so it's going to be inverted. Then we need to change the Eulers on your Y. Euler angles. Oh, yeah. This now kind of stops being, if you start rotating around, it changes the rotation you're going to be having, or you want to be rotating. Okay, so if you are here, or let's say if you are here, the Y rotation, as you can see, it's left because it's oriented, it's world oriented and not yeah, and not locally oriented. Okay, so instead of changing the rotations and trying to find out with the wall matrix, we can simply take the Y of this and change the camera Eulers and change the local Euler angles for a camera. Okay, so our transform will always remain the same value, I believe. Oops. Yeah, that's because we are adding on that. So we need to make a tilt angle and the pivot. No, pivot will be up and down. And tilt, let me see what I have here. Yeah, that's the look angle. So look angle should be all of this and just add the look angle here. Okay, so now we can rotate as you would expect. I know what's happening here. Yeah, I know what's happening. We need to kind of clamp things, be a little bit better. So, okay, if look angle is greater than 360, look angle make it 360 or look angle minus 360. Okay, if look angle is lower than 0, make it look angle plus plus look angle. yeah, look angle. Well, actually, I think if it's lower than 0, make it 0, or look angle minus. So this will reset it the other way, so we want to have look angle plus 360. And yeah, okay, we actually want the tilt angle as well. So I'm guessing all the move directions, up, down, right. Yeah, okay, no, this is correct. Actually, look angle worked fine. The tilt angle was what's misbehaving. Okay, so if tilt angle is less than 0, tilt angle 360. Tilt, yeah, plus 360. If tilt angle is greater than 360, tilt angle equals tilt angle minus 360. Just so that it circle around. Otherwise, we might have to work with quaternions, and I would like to avoid that, to be honest. Yeah, that's not going to work. It's not going to work because we want to have, this is now misbehaving. So let's try a different approach. Yeah, so the solution was much simpler than you might expect. We basically hardcode the Z to always be 0. So when the tilt angle is at, yeah, so when this, so technically we don't even need the Euler angles. We just need to set vector 3.0 to this. Yeah, so this now will be useless. Okay, that will force the Euler angles to always have 0 when it rotates on the Z. Okay, when of course this is in local angles. Hit play, up, down. Okay, so now we can move. We're now situated based on a camera. I think we need to change our torque to be the opposite way, so when pressing E, we should be going the other way, not this way. But yeah, that's pretty much the controls for it. Let's switch this around. So let's switch this. Well, actually we should be changing this on the input side. So that will be negative will be E, and then positive will be Q. Actually, no. This should be like this, yeah. Q and E. We just want to change the, let's see, our angles. We're going to say minus. So let's fix all of this. This goes handle move direction, and technically handle move entirely. We could just take all of this. Rotation. Okay, and this, the first one will be torque or pivot rotation, and this will be camera rotation. Okay, as you can see, it's really clean, and I think it works fine with update, so we don't have to worry about changing this. At least for now, we don't need to care about changing it into, you know, fixed update and so on and so on. So the last thing I would like to do for this, of course, we kind of need to be locking up our camera. So let's do this here. Cursor dot lock state locked and cursor dot lock state or is visible equals false. But of course, for the tutorials, I'm going to add if input dot get key down. I don't know. Let's say if I press keycode dot tab, if it's visible. So if it's visible, we're going to do this. If it's not, if it's visible, we actually want to make this, yeah, okay, false. If not, confined, not confined, none, and visible true. Just so that we can debug, you know. So the other thing I want to do is, if we look at our shadow now, we're going to see something ugly. And you're going to see a floating gun at this. So I'm going to duplicate this guy and I'm going to parent this underneath my camera as well. Let's reset him. Let's bring him about this. Now, of course, this needs this needs an animation, and of course this has a lot of junk in it, which I'm going to just delete after I unpack it. Okay, then let's try one thing. Let's say create animator, and let's do the animator controller, and let's say soldier or whatever, and I'm going to add this on this guy, and I'm going to go in it and I'm going to add an empty state. So what technically that should force him to do is to actually play a state which has no animations. So he would stay, let's see, yeah, that's exactly the pose I would like to have on him. Okay, because it looks spacey enough, but the only downside to this is that it's not, yeah, you can see that it's not really centered. So let me try one thing. Let's try via the animations. Yeah, we will have to do the entire animation, and I don't really want to do it on camera. Okay, let's do it then. So hold on. I'm actually just going to go on create. Let's say idle. Save that. And then let's change samples to maybe 20. And then while record is on, I'm going to go and place, let's see, where is he? Oh, it's not going to allow us to do that, as you can see. So anyway, we can't make an animation because there's some issues with this, I think. Yeah, it won't let us. But I guess we could just fix it from here. So I'm just going to fix the transforms to be sitting here. So I'll be back in a second. So, okay, we've just moved the transforms. And I'm going to delete this guy. I'm just going to take the gun as well and parent it underneath the right hand. Okay, now I do like to keep the weapon, or more correct, if we had animations for the gun, FPS animations that is, okay, then I will just turn all of this into just shadow casters. So it will does cast a shadow. But because I don't have a separate FPS, FPS model with the animations for this, I'm simply going to keep the gun only, and make this guy just be a shadow caster. But I can also duplicate this, put him outside, just so that we have, you know, somebody else to shoot. Change cast shadows to on, and then simply move him around, just so that we have something to see. In the air, you know. Now obviously this will work a lot better with spacesuits, but yeah, you get the idea. So now we have, oh, and I think it gets the entire, yeah, I think it gets the entire model to not be able to be casted. So I'm just simply going to move the weapon outside. Okay, so looking down and back, we can see that. Oh, yeah, it's they have an animator controller on them. So we can simply delete that on both of these guys. Yeah, so that's why. So hit play. Okay, and you can see the actual shadows. Okay, so I think for the base of the controller, this is working fine. Okay, we can take this and actually make it into a game. Now, I don't know how many things I want to add on this series, and I don't know how much interest there is for this series. So, you know what? Tell me in the comments, and of course, supporting me on Patreon and so on will also help to actually make this into a more fleshed out series. So it will be nice to have multiplayer as well and do other things onto it. Okay, maybe have different models and all these different levels. This is also an entire level, actually. This is a space station. So imagine having a deathmatch game onto a space station. Obviously this is just for show. And this was actually a city pack, not a game pack like this. Okay, so that's it for this one. I think I might continue with this, but as I said, feel free to voice your opinion in the comments. And of course, if you like to see more stuff, more games, more of everything, more series being done, consider supporting my Patreon so we can keep making all of these. I'll see you next time.